Wow. All right. So first thing we're going to do is talk through the homework and make sure everybody understands this. Okay. On this one, when we find the zeros, we find that they're all imaginary. Okay? And so we know it doesn't cross the x-axis. Now, how do we know the whole function's up above if you didn't have a graphing calculator?
Because it does not have negative in the front.
Very good. If we were to multiply this back, it would be 2x to the fourth would be our leading term, correct?
Yeah.
So it's an even degree function with a positive leading exponent. Even degree tells me it's going to rise. Positive tells me, even degree tells me same in behavior. Positive tells me rise. So we know it has to be up here. So the entire function is greater than or equal to 0. It's up here above this axis, isn't it?
Yes.
The y value anywhere on that function is greater than 0. That's what that means. Do you guys know that f of x is greater than 0?
Yeah.
It means the y value is greater than 0 everywhere, from negative infinity to positive infinity. Okay, so if it's greater than 0, it's obviously also greater than or equal to 0. So where is it less than 0 or less than or equal to 0? Nowhere. So we could say no solution, empty set.
Is that the sign for it, the 0 with this last bit?
There's two that we can use. This is one for the empty set, and then this is the other. It's a set with nothing in it. It's empty.
Empty set.
Yeah, that's empty set.
So never is unacceptable? Or no solution?
If you wrote out the words no solution, that's fine. Yes, ma'am.
What does it change like whenever it has like okay, well I did this all wrong because like I just did the zeros, like I did -4 and then -3 over 2.
Okay, that would work if the squared was out here.
Okay, so what do you have to do differently? Do you have to solve it like?
You have to do the complete linear factorization. So since this doesn't factor anymore, we said equal to 0 and solve. So these are two of ours. These are the other two.
Okay.
Okay, so this one is a little different. Because this one, that leading term, if we multiply this, would be -3x to the fourth. So it's even, so it's still the same in behavior, but it's negative. And when I solve this, once again, I get all imaginary zeros. So it's down here, opening down. So this time, my no solution is for where it was positive or equal to 0. And my from negative infinity to positive infinity is where it's less than or equal to 0. Does that make sense for numbers 1 and 2? All right, 3 and 4. When we solve 3, this one gave us imaginary. So do they make our sign chart? No, they don't make it. They don't count. But this is a 0. It's a rational 0, 4/3. It does make it. And if we test algebraically, or if we think about the graph, it's going to be positive on both sides of this. So this one, where is the function greater than 0? Everywhere but right here. Because right here it actually equals 0. So it's from negative infinity to 4/3, non-inclusive, union with 4/3 to infinity. Make sense?
Yes.
Okay. Well, this one says where is it greater than or equal to 0. So if we can include that 0, it's everywhere.
Oh, yeah.
So this should be another infinity. I don't know what happened to it. Okay, where is it less than 0?
Nowhere.
Nowhere. But where does it equal 0? Less than or equal to 0? Only at 4/3.
Oh, yeah.
Does that make sense?
Yes, ma'am.
Okay. This last one, this negative may have thrown you.
Yeah, those.
There's not just one negative here. Could I think of this as this times that?
Yes.
So if I factored out a negative, I'm actually factoring out
2.
two of them. So when I factor out two of them, it's a negative times a negative, which is a positive.
Then you.
Because that is even, this negative really doesn't matter. Does that make sense?
Well, then why do the other
So if this were an odd power, would it matter?
Yeah.
Oh yeah.
I think what I
Because
did
there'd
was-
be three of them, and a negative times a negative times a negative, it's still negative. But anytime this is raised to an even power, it has no effect on the end behavior.
When I did it, I think I
All right.
multiplied it.
So we have this set of imaginary, we have this rational, we can test and we see it's positive, positive. So these are our answers. Take a look and see if you have any questions. Could y'all quit fighting? Thank you.
keeps hitting the
Can you still find
He
it?
tried to kick me and he kicked my chair.
Okay, we're not fighting.
It sounds like I'm in the van with my children.
I think what I did when I did number 4 was I multiplied 3 minus 2x and I like multiplied it by each other to get like I think it was 9 plus 4x and then I solved it that way.
Okay.
But I don't think we
All right. Who did 5 and 6 and said, wow, those were way too easy and I obviously messed something up?
That made no sense.
They're just linear.
Yeah.
Linear.
Well, I mean, it made no sense that they were so
That they were
easy.
here?
Quite get
Okay,
that.
that they were so easy. Okay, good.
And then the last one,
All right,
I wanted not.
Then the last one I shot.
Is linear a
Yeah.
polynomial? Yeah, we can throw in linear sometimes. Now, number 7 I really liked, and let's talk through it.
Oh, I did it.
Yes, you will.
You will like that.
You got overwhelmed. Did you draw a picture?
Yes.
Yeah.
You
It's
drew
right
a picture
here.
of a box.
Yes.
Good. Did you
Pictures
label?
of boxes.
Yes.
Did
And
you-
I put little X's.
You labeled the X's.
Like,
Okay.
like you did
Okay.
in class the other day.
Oh, awesome.
And I wrote
Okay.
that. Yeah.
So when you found this length, which was 12,
Minus 2x.
we know we're going to cut out the 2 x's, so that's where we get the 12 minus 2x. And when you did this length,
15.
it was 15
I got that.
minus the 2 x's.
And you have an X.
So when we fold up the sides, to create the box, what is the height here?
X.
X.
I got the formula
All right.
right.
That's what I got.
Yeah.
Times
Oh, that's all I
the
got.
length times the width.
Yeah.
And this says not more than. So that
Less than or
equates
Less than or
less than or equal to.
Yeah, I did that.
I
All
got
right.
Good at finding
And then
formulas.
At this point, we're thankful that even though the top said do it algebraically, on the test we'll get to use our calculator.
Yeah. So
Okay?
we were supposed to use our calculator on that?
Yeah, sorry.
Okay.
I just
That's
stopped
why
right
I
there,
tried.
So, since we're following the directions on the sheet, which are my fault, you tell me what would happen next on the calculator.
We would
You
totally,
move it over.
You would move
You
over
would move it
the
over.
pages.
Now, before I start looking at the graph, because what does moving the 100 over do to the graph?
Since it equals
Sets it equal to 0.
Sets it equal to 0 by doing what?
Lower down.
Shifting it down to the x-axis. Sorry, I shouldn't have written it there. Okay, so that's what we've done. This minus 100 just causes that shift.
Whoa.
Wait, why do you have an X in front of it?
Because volume has 3 dimensions.
Oh.
Okay? So that's what we've done so that we can check out our zeros now. Before we start looking, this is a word problem. So I have to keep in mind what a reasonable domain would be in context of this situation. Because it's not just a function that goes on forever. So I have to think about, in context of this situation, what is the smallest amount
0.
X
and
could
then
be?
6.
0.
0.
Could it be equal to 0?
No.
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 What is the largest amount X could be?
6.
6.
How do you know?
Let me show you how they know. Our dimensions, here are our dimensions. Let's check them out. Right there. 1, 2, 3 of them. Length, width, and height. Here it's just X. Well, that's where the 0 comes from. Because it can't equal 0, because if it did, that dimension would not exist. And it couldn't make a box. It'd just be 2D, not 3D. Okay? Then we look at this one. We know we can't have a dimension that's equal or less than 0, right? So if x were 6 right here, this would make it 0. So anything larger than 6 would make it negative. Okay? If this were 7.5, we'd get 0. So of these two, which is the most limiting? 6. So the domain goes from 0 to 6. So when I look at the graph, I truly only care about anything that falls within this domain. If it's outside this domain, it's no good for me. Because this domain contains anything that would work for that problem. Yes, ma'am?
So, on my graph it goes past 6, so you would just stop at 6?
I'm getting there.
Yeah, you put the
Yeah.
window at 6.
All right, so all of you that weren't able to do it because you were being great students and following the directions,
Yeah.
if you guys could take out your calculator right now, and let's see if you can do it with a
I saw
calculator.
the solid already, and I was like, shoot.
This whole part was like, wow. How is this?
But yeah, I know. That was easy. These two were actually like, not stupid.
With these.
I was just really charges for like 2 days.
Did it completely die?
Oh yeah, mine's fast.
Or did it?
And you broke your calc.
Again.
Again.
I was someone tried to
Is he done? Oh, it does have a reset button. Did you push the reset button?
Just
Graph. Which graph?
Guys, I'm so pissed.
Oh my goodness.
This
I didn't graph very well.
You might want to grab
Be on. Please be the very good, right?
It is not the
Yeah.
It
answer.
was not the answer.
We gotta get the flag up.
Oh, that's just,
What did you do to your calculator? Doesn't work.
She didn't do anything to it.
it just doesn't like her.
It's not charging.
What should we put the Y maximum as, or does it really matter?
All right. When it was plugged in, did a little light or anything come on?
Yeah, the light on the side was
Okay. When it's plugged in, hit that reset button,
Right.
and let's see if magic happens.
Ms. Lee, what would you
Or if
scale
it
everything
doesn't
at?
do it,
Oh, I didn't do mine in 100.
What are your
then
Ah.
they have to contact TI and get your replacement design.
Let me see it, I'll save you.
Yeah.
Ms. Lee, what would you do with that?
You lost your noggin?
Here, you can stay with mine.
And then it's like 4.1, like 4.1 or 4.2.
All right. Did you find this point, and you probably didn't find this one at all, did you?
I saw it.
No.
You saw it, but you don't need it, do you?
No.
So you
I
may
shot
not
it.
have found it.
It's wrong.
Okay, so could your graph look something like this? It went down, it went up, it went down, it went back up.
It could be that.
Okay.
That's what I did.
Let's concentrate on what this question is asking for. Less than 0. Less than is here, isn't it?
Yes.
Less than is here, isn't it?
So it's
We want
gonna be
it. If we were testing algebraically, it would be our negative ones, right? That's our less than. So this is all we care about. But it can only exist over this domain.
because it's
So even though this goes to negative infinity, we are starting out at
0.
0.
Because
So 0,
context to the problem.
yeah, up to this point. Union with this up to, now don't be fooled, it's not 8.61
6.
because that doesn't fall into our domain, so it has to stop at 6. Do you see how the 0 and the 6 came from our acceptable domain?
Yes.
Yes.
Okay. Now, had I worded the directions correctly, and you were allowed to use the calculator on this problem, do you think you could do it?
Yes.
Okay.
Well,
If you're not using the calculator, then you just use stuff that's, you make it all one equation, then you synthetically.
Sid, if I didn't give you the calculator, you would have to find some way
To reduce
to
it.
factor this.
that would have been hard.
Which would suck.
So if we took a 4 out, it would be 16 here.
And
Yeah, that's not gonna help us.
sorry.
Yeah, you don't have a factoring method for this problem.
So this would have just been a calculator's only part of it. Alright.
Yeah.
Man, that made
Because
that
even
makes me
if
feel better at
you
least.
know, we can test for rational roots, but we can tell we don't have any. Yeah. So that's not helpful either. All right.
You would have to like do some weird exponent when you're reduced, or some weird irrational number when you were synthetically dividing to get.
I'd have to give you something. You couldn't do this problem without a calculator,
All right.
even with every method we know.
So our test is Thursday, Friday next
That is a good point. So remember, we edited the calendar because of my goof.
It's all right.
All right. So this is what it looks like. Whoops. Let me put it on the notes. Anybody that's not here, Jake, can be aware of this also. So the old calendar said these words, but then gave no assignments, and then it repeated them down here for some bizarrely odd reason. So today we are going to look at compositions and operations with functions. And your homework is out of your textbook. Tomorrow we're going to investigate inverses and one-to-one, what that means in terms of functions. And then this will be your homework. Monday, you'll get the review. You'll work on it all day long in class. We'll go over the review on Tuesday. Now the review is a nice packet. So if you have a weekend that looks clear and you'd like to get a head start on the review, remind me tomorrow and I'll pass those out. Okay, I've already run them off. So we have 2 days scheduled for the review. So this would be a work day more. This would be a ask questions day. And then we have your test in 2 parts. A no calculator part on Wednesday, calculator part on Thursday, and then we start our next unit.
Celebrate that day.
We celebrate a little bit every day. Yeah. All right, so that's what's coming up. So today, this is not my first slide. Hold on. Today we're going to take a look at composition and operations of functions. So we're going to start off with operations. Now, in my 3rd period class, I had a student that didn't have much to do last night, and he chose to work ahead, and he already did all the homework for this unit, this tonight and tomorrow. He goes, Miss Willoughby, this is really easy. So, that is encouraging for you guys.
Is he smart?
Who is it?
Most all my students are.
Is it Luke Miyazaki?
No, it was not.
I feel like Luke would have told me.
Okay.
We get a secret password from Jake.
Was it
so
Carmel
you
Holt?
actually watch the video.
He's in the ATAG, I think.
If Jake's feeling well enough, I'm sure he'll go for
No way.
No, he's an
No
egg.
way.
He's in.
It's been doing any good.
He has strep throat, so that's usually not very good.
Hi, Jake.
If he got medication,
It goes away
then
like
he
4
probably
days.
feels better today.
Yeah.
All right.
What does Jake have? Strep.
Okay. So, operations with functions. Now, if we look at this, what do you think you did on this first problem?
Straight up.
You add. That's it. You add like terms. So 2x squared plus x squared is 3x squared.
Squared
Negative
minus
x.
minus
And
4.
minus 4.
This will be. This is easy.
Thank you.
Wait,
It's
is
not
that
actually
wait,
easy.
That's it.
Oh my god.
do we have to pass?
Alright, no, we can just leave it.
Sweet.
Because this didn't say factor, it said find the sum. So we're adding up these 2 functions. Now,
F plus
have we already done something like that? Yes. We did it when we first studied polynomial expressions, but they weren't functions. So now they're functions. So if I added this parabola with this parabola, I'd get this.
is like when
Why would you want to add
I
functions?
dilated a circle by a linear function.
Combining functions can be helpful. And as we do more and more with math, you'll see that. Yep. Yes, Sid.
Why does it say F minus G? Is that just
Because next we're going to subtract
Oh, okay. I
it.
thought that was like part of the like go.
It's just like,
You said it like you were talking to a 4-year-old.
Alright. So, the next question does just ask us to
I thought
subtract.
that
And what
probably
you
saved
have to be careful with subtraction is you are subtracting the entire function g from f. You are not just subtracting the first term. So you can think of it as, oh, there's function f, and I'm subtracting from that g, which means I have to distribute that negative. That is the only thing you have to be careful with subtraction, is to make sure you distribute the negative throughout the function that you're subtracting. So this gives me x squared minus x plus 6.
yeah,
Okay.
FG.
What do you think we're doing with these?
Multiplication.
Multiplication. So, a small dot, or the two functions side by side, indicates multiply your polynomial functions.
Yes. Just as X.
And so this, once again,
Wait,
is nothing new.
is this like the thing?
That's a homework right there.
Okay, so we're going to distribute. We're going to distribute, and we'll be done. So we get 2x to the 4th minus x cubed plus x squared, and then we get minus 10x squared plus 5x minus 5. So this simplifies to the product of f and g is 2x to the 4th minus x cubed minus 9x squared plus 5x minus 5.
I will just take a test on this.
This will be.
How about we'll do that. We'll take a test that has this on it next week.
Next Wednesday, Thursday?
No thanks.
That's even better. I like those things.
Next Thursday and Friday.
Good one, Ryan.
Okay. Now,
On it. I mean, that's all
when
it
we
is.
were looking at the last word problem, the domain was very important.
Yes.
The domain is really always important when we're thinking about functions.
Sadly.
Now this is, what would this graph look like?
Parabola going.
Parabola. What's the domain of every parabola?
Negative,
Positive.
Okay, what's the domain of this function?
Same.
It's a parabola. It's a quadratic, so it has the same domain. So our domain was not restricted on either function, was it?
No.
So when I find the sum or the difference or the product, will the domain be restricted?
No.
No.
It should not be.
No, it's not. Okay, so what operation is left?
Division.
Division. All right. So we're going to try some new functions for division.
Can we go back there?
Yes, you may.
I like two.
No, that's fine. Thank you. Let me know when you're ready.
Thank you.
Okay, so
Is this a usual?
no, this is division. So here is our division of functions, and you'll be happy to know that you don't have to do long division.
Oh, thank you.
Yeah.
Wait, but I like
So-
long division.
Okay. Oh,
No.
well, I was wrong. You're not happy to know that. So h of x and n of x are represented by those two polynomial functions. So if we had to find h divided by n of x, we would write h over n, and see if we could simplify it all. So all you have to do is simplify. You don't have to divide. We can leave the answer just like this if it doesn't simplify. And this one doesn't.
Wow.
But we do have to be careful. Because what I'm left with is a function that has x in the denominator,
Which is not good.
which might not be good. Because what can the denominator never equal? 0.
0.
Because division by 0 is undefined, correct?
Yes.
Oh, I
So-
It's plus 3.
Because of this, that would cause a restriction on the domain.
So just multiply x out.
Okay? So what value could x never have in this situation?
0.
Nope.
No, because 0 would still be 7
Oh,
over 3.
oh.
It would be
Zero's okay.
Negative 2/3.
We've got a
Negative
1
3
half.
halves.
3 halves.
Negative 3 halves.
Hey, I say gut.
Negative 3 halves. So we do have a restriction on our domain.
I said it.
I did hear you. You said it. All right. X cannot equal negative 3 halves because if we plugged in negative 3 halves, that would give us a denominator of 0, which is not defined. Okay. So if we were to graph this, would there be a y value that corresponds to this x value?
No.
No, because this x value is not a possibility. And that'll lead you into rational functions, which we'll do next year.
Wait,
Next
so
year.
does that mean
All right,
Statistics
so
next
this would be your next
Math course.
pre-calculus.
Okay.
Pre-calculus. So this would be our restriction. This would be our actual domain. It can be everything but that.
Well, that means there's a graph.
Okay, so this is the restriction. Now, the answer to any of these division problems is both parts. With division, you must state any restrictions on the domain. So what we've been doing, and you guys are really good at doing this in your head, so you don't even usually do that. If you set the denominator not equal to 0 and then solve, that gives you your restriction. So if I had set this denominator not equal to 0, because it can't be 0, and solved, you see that's where the negative 3 halves came from. So x cannot be negative 3 halves. Make sense?
Yeah.
Okay. So it takes both parts because there is a restriction with division. Anytime there is a variable in the denominator, there is a restriction on that domain. So let's try a new one. F of x equals this, and g of x equals this. So we write it as a fraction.
So it's just over x.
What's my restriction? Nice and simple this time, isn't it?
Negative 1.
Negative 1. Now, this could be my answer if it were completely simplified. But it's not. Y'all see it real easy?
Yes.
Great. So we take out the 2x, and we're left with x plus 1. And we had x plus 1 in the denominator. So it cancels out. So our answer is f divided by g of x is equal to 2x with a restriction where x could never be negative 1. Okay, now, what I want you to do is take out your calculator, and we're going to graph this, guys. Okay, so this is how we're going to do it. This is how we're going to do it, guys. Under y1, you're going to type in 2x squared plus 2x divided by x plus 1. And then I want you to zoom 6 and look at your graph.
So I have to put the 2x squared.
Yep, gotta put all this in.
What do you think?
It is a lot. So you see how this crazy stuff does simplify to this. Did you get this line? And that line has a slope of 2, doesn't it?
Yeah, it does.
Okay, now,
How do you set this in?
what I want you to do next is look at the table.
Error.
And I want you to look at the table where x is negative 1.
There's
Oh my
a
goodness.
point.
Why does it say error?
There's a point in
Because
the graph.
There's
There is
There's just
a
like a
X equals
there is a missing spot
At
in
zero.
the graph.
A negative one. A
Crazy.
negative one. A negative one. Oh my goodness.
There is a missing
yes.
spot.
This calculator
Because
is
it
so
will never
smart.
equal negative
Because
one.
it can never equal negative 1.
I see.
Okay, now, some of your calculators won't have this missing spot,
That is bonkers.
but there is a missing spot right here.
Mine does
It's-
not
Mine doesn't have it
Mine
there.
doesn't have that much sweat.
It's called a hole in the graph.
Mine does
Mine
not.
has it somewhere else, but not there.
Yeah.
Okay,
She was like,
Well-
Okay, that's why we use this calculator.
that's what is there. Does that make sense?
Yeah. I guess.
oh my goodness.
Pretty cool, huh? And so next year, you're going straight for rational functions in one of your units. You won't have to start off with division like we do. You'll just be given rational functions. You're going to learn about, in a rational function, where do I have holes? Where are there asymptotes, vertical asymptotes, horizontal asymptotes, slant asymptotes? It's so good.
Oh, yay.
Pre-calculus. Pre-calculus. All right.
Your
Uh,
junior.
Your junior year. Everybody on the accelerated track, no matter which level, takes it their junior year.
What did normal classes take junior year?
What y'all are doing right now. Okay. Last concept is called composition of functions. Now, part of this we've done. I'm going to start out just by evaluating functions. Compositions means I'm plugging something into something else. I'm composing. But we're going to start off with evaluating because we did this in APAC, and you already know how to do that. F of 2 is, well, plug it in. 2 times 2 squared minus 1 is 7. So F of 2 is 7. You guys remember that?
Of course.
All right. Now, so the new part would be a composition with that. We find F of 2, and then we plug that into G. And we can write that a couple ways. It can be written G of F of 2, or with this open circle, okay? Now, this composition you'll see here at Stars Mill High School and college is what you mainly see in upper level mathematics. But the open circle is going to mean the same thing. I like this form better. It's easier to type. I don't have to go hunt for this symbol. I just like it better. Makes more sense to me too because it looks like 2 is plugged into F, which is plugged into G. Okay, we just evaluated F of 2. We know it's 7. So now we do G of 7, and G of 7 is 9. So G of F of 2 is 9.
Swag.
Yeah. All right.
Yeah,
How did you pick 2? Yeah.
How'd I pick 2? I literally just picked 2.
Why?
Okay, well here I picked 1, here I picked 5. I can pick any number.
Oh, okay.
Okay, you try 3 and 4.
And those are all using those same. Wait.
No waiting, you do it.
3.
Oh, no.
What happened?
G of F.
Oh, legit.
Yes, yes, oh.
Oh, I didn't do them.
G of F of G of 1. Now that.
This is not multiplying, this is composition.
This is
This
this is fun stuff until we get to like higher degree polynomials, and then we.
I don't know what.
This is fun stuff. Is that what you said? You said
Neither
fun
do I.
stuff.
This is like the first thing.
Well, compared to other stuff we do.
Okay, guys?
I'm very confused.
Oh, this is not assuming that.
I'm lost too.
Okay, that means y'all didn't catch it last year. If you're lost right now. So let's go over it slowly. We start from the inside and work our way out.
Oh.
G of 1. I plug in 1. What do I get out? 3.
Oh.
Now I do f of 3.
Oh my goodness.
Plug in
I
3,
was kidding.
17.
17.
Plus 2.
Now I do g of 17,
19.
19.
Alright, I'm good.
So g of f of g of 1 is 19.
Alright, I got it. Thank you.
Okay, you try
Nine.
then
Yeah,
number
I'll
4.
do 5.
9.
Yeah.
Wait.
Don't tell me.
Yeah, Joel. I'm with you,
I
buddy.
thought we were supposed to do both.
Alright.
5.
Yeah, I know. Joel, I got you, bro.
And then
We said before 9.
yes, bro, let's get it.
It's a lot easier than I thought it was. It just I saw all the parentheses and everything, and I was so like, oh,
I didn't even see before.
I understand.
Alright, did we get 9?
I got it.
Okay. Alright, last thing. Really kind of is the same thing. It's still plugging in. But instead of plugging in a number, you're not evaluating.
Plug in a function.
You plug in the whole function. So let's play with some new functions.
Wait, so that's
Make some
underlined?
new friends.
That's like multiplying the functions together.
Now, when we're dealing with the entire function, does the domain matter?
No.
No.
Sure.
Yes, yes. No,
But there's
yes.
no restrictions on the domain.
There's not on this one, is there?
No.
But there is on the
I
other
don't
one.
have.
Is there on this one?
No.
No, because it's a line.
That
Okay,
one
good.
is. H of X is.
But this one, there is.
Jeez Louise.
Okay, you don't know what this graph looks like yet, but you can reason this out.
It can
Can-
equal
can
negative.
Can I
one.
graph a square root that is negative?
No.
No. So, do you see that this would make sense for the domain?
Yes.
It would need to go from -1 to infinity. If we plugged in -1, that would work. We just get 0.
Oh, yeah.
But anything smaller than -1 wouldn't work.
Is that first one?
All right,
2x
so
cubed.
this composition deals with f and g. Will my domain change? No.
Is it?
Okay, so we take all of g and plug it into f. So instead of x squared, it's 2x minus 3 squared,
Oh, my.
which is 4x squared minus 12x plus 9.
What's not
And no restriction on the domain.
That's the entire problem.
That's it.
I don't.
We-
You go through that one more.
Okay, what we did was we plugged G into F. G got plugged into F.
Oh.
So the 2x minus 3 is now what's being squared.
Okay.
I think I
Like
just
we've
blanked
done
out for like a
something
second.
similar
Like
to
5
this,
minutes
Yes.
ago,
like
and then something.
solving systems.
Okay, now F gets plugged into G. Okay, so now we're going the other way. F gets plugged into G. So we get 2 times x squared minus 3. Well,
Oh wow.
that's easy. 2x squared minus 3.
Oh, okay. I was
Is
it not more simple?
Okay, it's pretty now.
Remember.
Just like before, we could use the open circle for composition. We can do the open circle here. If we said G open circle F, the open circle is G, the composition of G with F. That means plug F into G. So it could be written either way. Means the same thing. All right, now we're going to plug H into F. Domain, thinking about the domain always comes first.
Always.
The domain of H is restricted, isn't it? So that's going to make a difference when I plug it in here, isn't it?
Yes.
Because this domain is restricted, the domain of the composition is also restricted. Got it?
So when you're multiplying one to another, it'll still have the same restrictions.
Okay, so when we plug this into here,
Then it's just x minus 1.
not
Or
x
x
minus.
plus 1.
Okay. So this composition, f of h of x, is just x plus 1, but the domain only goes from -1 to infinity.
The line just stops.
So it's a line that stops right here.
It's a Ray.
It is a ray.
Oh,
Very good.
Ooh, Joel. Joel, I like it.
Fourth grade math right there.
Pretty great.
We learned
I'm pretty sure we remember
Okay.
last year.
Homework's out of the textbook. It's the exact problems on your calendar that it says for homework.
Oh my gosh. That is
Now, when I say calendar, I mean updated calendar.
Okay.